Welcome to Gadgets and Software again. Thanks for watching my videos. Today I have come up with Oracle Release 23C and I'm going to talk about Oracle Database 23C's new features. So let us start with introduction. Oracle Database 23C free version, that is like a 23C free developer release, is the first release of the next generation Oracle database, allowing developers a head start on building applications with some of the new 23C features. So, here are some of the features. They bring 14 new features. So, let us start knowing about it one by one. One is the JSON relational duality. The second is operational property graphs in SQL. The third is microservice support. The fourth is lock-free column value reservations. The fifth is Kafka APIs for TX event queue, which is part of a microservice support. The sixth is JavaScript stored procedures. Seventh is the application usage domains. The eighth is metadata type and SQL enhancements. Ninth is up to 4096 columns per table. 10th is improved machine learning algorithms. 11th is schema privileges. 12th is developer role. 13th is SQL Firewall. 14th is Azure ADO Auth2 integration. Let us understand one by one of these features of 23C database. First is JSON relational duality. It is data can be transparently accessed and updated as either JSON document or relational tables. Developer benefit from the strength of both, which are simpler and more powerful than object relational mapping ORM. JSON relational duality have few more uh, features that I'm going to describe now. First is JSON relational duality. JSON schema, XML and JSON search index enhancements, enhancement to JSON underscore transform, JSON slash JSON underscore value will convert PL/SQL aggregate type to or from JSON. JSON underscore array constructor by query, ordered in JSON serialize, pre-checkable constraint using JSON schema, predator for predicates for JSON underscore value and JSON query, tools to migrate JSON text storage to JSON type storage. So these are part of JSON relational duality. JSON relational duality views are fully updatable JSON views over relational data. Data is stored in relational tables in a highly efficient normalized format but can be accessed by applications in the form of JSON documents. Duality views provide you with game-changing flexibility and simplicity by overcoming the historical challenges developers have faced when building applications using relational or document model. Now coming to JSON schema. JSON schema based validation is allowed with the SQL condition is JSON and with the PL SQL utility function. A JSON schema is a JSON document that specifies allowed properties and the corresponding allowed data types such as field names and whether they are optional or mandatory. By default, JSON data is schemaless, providing flexibility. However, you may want to ensure that JSON data has a particular structure and typing which can be done via JSON schema validation. Now coming to XML and JSON search index enhancements. The Oracle text XML search index syntax and JSON search index syntax are now consistent. Additionally, the performance of JSON and XML search indexes has been improved. Using the same syntax for XML or JSON search indexes and better performance increase productivity. Enhancement to JSON underscore transform. JSON underscore transform is extended to support right hand side path expressions, nested paths, and arithmetic operations. A sort operator is supported which allows sorting the elements in an array. JSON underscore transform is the main SQL operator for modifying JSON data, both for on-disk updates and transient changes in the select clause of a query. This enhancement increases update capabilities such as arithmetic calculation and operations on nested arrays and raises developer productivity. Coming to JSON slash JSON underscore value will convert PL SQL aggregate type to or from JSON. The PL SQL JSON constructor is enhanced to accept an instance of a corresponding PL SQL aggregate type, returning a JSON object or array type populated with the aggregate type data. The PL SQL JSON underscore value operator is enhanced so that its returning clause can accept a type name that defines the type of the instance that the operator is to return. JSON constructor support for aggregate data types streamlines data interchange between PL SQL applications and languages that support JSON. Now coming to the next, JSON underscore array constructor by query. A subquery can be used as an argument to SQL JSON function JSON underscore array to define the array elements. This functionality is part of the SQL JSON standard. This feature increases your developer productivity and higher interoperability with other SQL JSON standard compliant solutions. Moving on to the next, ordered in JSON underscore serialize. The SQL function JSON underscore serialize has an optional keyword ordered, which reorders the key value pair alphabetically in ascending only. It can be combined with optional keyword pretty and ASCII, that is PRETTY and ASCII. Ordering the result of serialization makes it easier to both tools and humans to compare value. Coming to the next is pre-checkable constraint using JSON schema. To avoid sending invalid data to the database, an application can often pre-check or validate it. PL SQL function dbms underscore JSON underscore schema dot describe provides JSON schemas that apps can use to perform validation equivalent to that performed by database column level check. constraints, and it records constraints that have no equivalent JSON schema. Applications can also check with columns are pre-checkable with a JSON schema by consulting static dictionary view, that is all underscore constraint, db underscore constraint, and user underscore constraints. When you create or alter a table, you can use keyword pre-check to determine whether column check constraint can be pre-checked outside the database. If no equivalent JSON schema exists for a given pre-check column check constraint, then an error is raised. Early detection of invalid data makes application more resilient and reduces potential system downtime. All applications have access to the same information about whether data for a given column is pre-checkable, and if so, what JSON schema validates it. Coming to next, predicates for JSON underscore value and JSON underscore query. JSON path expressions with predicates can be used in JSON underscore value and JSON underscore query. The functionality is a part of SQL JSON standard. Applying JSON path expressions more widely for querying JSON data boosts your developers' productivity and simplifies code development. Coming to the last point for this JSON relational duality, tools to migrate JSON text storage to JSON type storages. The new PL SQL procedure dbms underscore join dot JSON underscore type underscore convertible underscore check checks whether existing data stored as JSON text can be migrated to JSON data type. There are several alternative ways to migrate the data after this check succeeds. Leveraging the binary JSON data type format provides the best performance for processing JSON data. Providing a simple and easy way to ensure existing data can be transferred successfully to binary JSON format helps you to adopt the preferred storage format for JSON. So this is all about JSON relational duality. Let us go to the next feature. It is about operational property graphs in SQL. Developers can now build real-time graph analysis applications against operational data directly in the Oracle database, utilizing its industry-leading security, high availability, and performance capabilities. So it comes with four features, that is under property graph, native representation of graphs in Oracle database, support for the ISO IEC SQL property graph, queries, SQL/PGQ standard, and next is using JSON collection as a graph data source, use native representation of graphs in Oracle database with graph tools. So let us understand each. Basically, there are many other databases for graphs. So Oracle has brought in this uh, operational property graphs in SQL. So let us understand more. So we start with the native representation of graphs in Oracle database. Oracle database now has native support for property graph data structure and graph queries. Property graphs provide an intuitive way to find direct or indirect dependency in data elements and extract insights from these relationships. The enterprise grade manageability, security feature, and performance features of Oracle database are extended to property graph. Developer can easily build graph applications using existing tools, languages, and development frameworks. They can use graph in conjunction with transactional data, JSON, spatial, and other data type. Next is about support for the ISO IEC SQL property graph queries standard. The ISO SQL standard has been extended to include comprehensive support for property graph queries and creating property graphs in SQL. Oracle is among the first commercial software products to support this standard. Developers can easily build graph applications with SQL using existing SQL development tools and framework. Support of the ISO SQL standard allows for greater code portability and reduces the risk of application lock-in. Next, moving on to property graph, use JSON collections as a graph data source. SQL/PGQ queries can be executed on graph represented as a JSON column. SQL PGQ is the ISO standard for property graphs. Developers can store a graph as a schema-less object in the database. Verticals and edge in a graph can have varying number of types of property. Moving on to next property graph, use native representation of graphs in Oracle database with graph tools. Developers can visualize graphs and graph query results that use the native property graph object in Oracle database. Developers can query, analyze, and visualize graphs created by SQL DDL statements using built-in advanced tools in Oracle database. Existing applications can use this native representation of graphs without changing tools and UI. So this is all about operational property graphs in SQL. Let us move to the microservice support. So alongside Oracle's already comprehensive support for microservices, new functionalities make it simpler to implement cross-service transaction. So one is the Kafka APIs for TX event queue. Second is Prometheus Grafana for Oracle. Python and REST drivers for transactional event queries for TX queue, that is the event queues, that is the TX event queue. Transactional event queues propagation. Let us understand more about that. Let us understand Kafka API for TX event queue. Kafka API for TX event queue is like a transactional event queues now support the Kafka producer and Kafka consumer classes from Apache Kafka. Apache Kafka, let us have an understanding about Apache Kafka. Apache Kafka is a community distributed streaming platform that is horizontal, scalable, and fault tolerant. Kafka is run as cluster run on one or more servers. Each Kafka cluster stores streams of record in categories called topics. Each record consists of a key, a value, and a timestamp. Kafka APIs allow application to connect to Kafka cluster and use Kafka messaging platform. Basically, if you see the streamings in a match, uh, that is a streaming platform, live matches. So they use this methodology. This this is a part of that streaming community. Kafka Java clients for transactional event queues. Oracle Database 21 introduces Kafka application and compatibility with Oracle Database. Oracle Database 23 provides more refined compatibility for Kafka application with Oracle Database. This provides easy migration for Kafka Java applications to transaction event queues. The Kafka Java APIs can now connect to Oracle Database server and use TXQ event as messaging platform. So we understood about Kafka APIs for TXQ event. Now we move on to Prometheus Grafana for Oracle. Prometheus Grafana for Oracle will provide database metrics for developers running in Kubernetes, Dockers, K8s environment. Database metrics are stored in Prometheus, a time series database, and a metrics tailored for developers are displayed using Grafana dashboards. A dashboard where a database metrics exporter aids the metrics exports from database views into Prometheus time series database. Developers of modern applications like microservices use observability at the app tier and often overlook the database tier. Data driven applications don't get a full picture of execution and performance of the application. Traditional databases metrics are seen through AWR reports and Enterprise Manager, which are more targeted to the DBA and less to the developers. So basically, if there is something that there's a flaw or something issue with the database, we generally the DBAs use generally the AWR report and Enterprise Manager that the OEM sends the data from server to the enterprise manager grid, so we get collect all those details, and DBAs have all those reports to understand something issue or some changes in their database, but the developers they don't have. For developers and architects, Prometheus and Grafana have become the tools for configuring metrics metrics dashboards, setting alerts, and taking remedial actions. Developers can now tie in app tier metrics, Kubernetes container metrics, and Oracle database metrics on behalf of the application together in a single dashboard. In addition to metrics, logs and tracing is also enabled to truly get unified observability on a single pane of glass. Coming to Python and REST drivers for transactional event queues, that is TX event queue. Database 23 introduces support in new languages for transactional event queues. TXQ events can now be used in Python and with REST APIs. REST APIs implemented to be like Kafka Confluent REST APIs. TX event queues already have support for PL/SQL, C++, and Java using JMS or JDBC. This feature increases developer productivity by allowing REST APIs applications to take advantage of transactional event queues to handle application and data events. With increasing popularity of Python for machine learning languages, machine learning applications, TXK event is in the Oracle database can now be part of the machine learning application data and events infrastructure. Coming to the final part of the microservice support, that is a transactional event queue propagation. Queues are used widely to send and receive events and messages between application, increasingly being built as microservices. Transactional event queues are queues built into the Oracle database. Queue propagation allows multiple databases to act as producers and consumers of events and messages. Producer application can send events in query in one database, set up queue propagation to a remote database, and consumer application can consume event in queues in the remote database. Queue propagation is used to consolidate critical events and data from remote location to a central location for consolidated processing. Propagation is used to operate transactional event queues. Has a reliable and secure event mesh with multiple queues across multiple databases participating to send event and messages across the enterprise reliably and to remote subscribers with permissions. TX event queues support exactly once messaging with which makes it simpler to build and test applications. This is all about microservice support. Let us go to the next feature, that is lock free column value reservation. Lock free column value reservation allows applications to reserve part of a value in a column without locking the row. For example, the reserve part of a bank account balance or reserve an item in inventory without locking out all other operations on the bank account or item. Lock-free reservation enables concurrent transactions to proceed without being locked on updates of heavily updated rows. Lock-free reservations are held on the row instead of locking them. Lock-free reservation verifies if the updates can succeed and defers the updates until the transaction commit time. Lock-free reservation improves the end user experience and concurrency in transaction. This is all about lock-free column value reservation. So basically, the lock-free column value reservation um, provides an in-database infrastructure for transaction operating on reservation columns to enable concurrent transaction to proceed without being blocked on updates made to reservable column. Issue automatic compensation for reservable updates of successful transaction in an aborted saga. Um, Here's how lock-free reservation enables applications to include concurrency and auto-compensating features into their transaction. Declaring a reservable column, reserving a transaction update, verifying and deferring an update, auto-compensating successful updates in a failed transaction, ensuring durability of a reservable updates. Moving on to the next feature, that is JavaScript stored procedures. Developers can now create stored procedures using JavaScript in the database. This functionality also allows developers to leverage the huge number of JavaScript libraries. It has like a multilingual engine JavaScript module and environments, multilingual engine module calls, multilingual engine post execution debugging, multi-engine JavaScript SODA API, multilingual engine JavaScript support for JSON data type. So let us discuss more about it. So multilingual engine JavaScript modules and environments. Multilingual engine MLE modules and environments allow JavaScript code to persist and be managed in the database. Call specification provides a mean to call JavaScript function from an MLE module anywhere you can call PL/SQL function. The introduction of JavaScript models and environments as schema objects in Oracle database allows developers to follow established and well-known workflow used in client-side JavaScript development. Complex projects can be broken into smaller, more manageable pieces worked on independently by team members. Multilingual engine module calls. Multilingual engine module calls allow developers to invoke JavaScript functions stored in modules from SQL and PL/SQL calls, call specifications written in PL/SQL link JavaScript to PL/SQL code units. Thanks to module calls, developers can use JavaScript functions anywhere PL/SQL functions are called. Multilingual engine post execution debugging. What is it about multilingual post execution debugging? Oracle multilingual engine allows developer to debug their JavaScript code by conveniently and efficiently collecting runtime state while the program is being processed. A method referred to as post execution debugging. After the code has finished running, the collected data can be used to analyze program behavior. discover, and fix bugs. Post-execution debugging offers a convenient way to extract runtime state information from a JavaScript code unit at runtime without having to change the observed code. So let us understand what is all about multilingual engine JavaScript SODA API. SODA API full form is Simple Oracle Document Access. Is a set of NoSQL style APIs that let you create and store collections of document, in particular JSON, in Oracle database. Retrieve them and query them without needing to know SQL or how the document are stored in the database. With the introduction of MLE, JavaScript support for SODA, that is Simple Oracle Document Access, documents exists for client-side and server-side development. Supporting the Simple Oracle Document Access API is in JavaScript gives developer a choice between using JSON in a relational or NoSQL way, simplifying the development process and improving the portability of code. Now we understand about what is multilingual engine JavaScript support for JSON data type. Support for JavaScript object notation, that is JSON. So JSON stands for JavaScript object notation. Is an integral part of Oracle database. Oracle support JSON natively with relation database features, including transaction indexing, declarative queries, and views. A rich set of SQL functional is function is available to manipulate JSON in a relational model. Oracle Multilingual Engine fully supports JSON, both dynamic MLE as well as MLE model calls support interactions with the JSON data type. JSON and JavaScript objects are closely related, forming a natural match in such a way that makes working with JSON very easy with JavaScript code. So this is all about JavaScript stored procedures. So now let us move on to the next feature, that is application usage domains. Application usage domains allow developers to declare the intended usage of data, that is columns, in a centralized and lightweight manner. For example, declare a column holds an email, URL, password, currency, etc. Apps can use application usage domains to automatically generate code or verify values. An application usage domain is a dictionary object that belongs to a schema and encapsulates a set of optional properties and constraints for common values such as credit card numbers or email addresses. After you define an application usage domain, you can define table columns to be associated with that domain, thereby explicitly applying the domain's optional properties and constraints to those columns. With application usage domains, you can define how you intend to use data centrally. They make it easier to ensure that you handle values consistently across application and improve data quality. This is all about application usage domains or domains. So coming to the next feature, there is many data type and SQL enhancement. So following are the among the many data types and SQL enhancement, there is SQL Boolean data type, direct join for update and delete statement, Unicode 15.0 support, select without from clause, group by column alias or position. These are the new thing that is being added, or it's an enhancement added to the SQL and the other data types. Coming to the next is about up to 4096 columns per table. Database tables now support up to 4096 columns. This feature simplifies the data development of applications needing large number of attributes such as ML and IoT. ML is machine learning and IoT is internet all about things. So let us discuss about white tables. So the maximum number of columns allowed in a database table or views have been increased to 4096. This feature allows you to build applications that can store attributes in a single table with more than the previous 1000 column limit. Some applications, such as machine learning and streaming Internet of Things application, IoT application workloads, may require the use of denormalized tables with more than 1000 columns. You now have the ability to store a larger number of attributes in a single row, which for some applications may simplify application design and implementation. Moving on to the next feature, improved machine learning algorithms. New improvements for Oracle in database machine learning algorithms make it simpler to categorize text and data while offering better performance and flexibility. Explicit semantic analysis support for dense projection with embeddings. The unstructured text analytics algorithm, explicit semantic analysis, is able to output dense projection with embeddings which are functionally equivalent to the popular doc to vec, that is document to vector representation. Producing a doc to vec representation is useful as input to other machine learning techniques. For example, the classification and regression to improve their accuracy when used solely with text or in combination with other structured data. Use cases include processing unstructured text from call with from call centers, representatives, nodes. Basically, the call center representatives, when they are taking directions or updates from the customer, they take the notes when they have a conversation with their customer, or physician notes on patients along with other customers, or patient structured data to improve prediction outcomes. Coming to schema privileges, schema privileges can now be granted at schema level. This feature um, simplifies the privilege management process and as a result makes it easy to secure databases. Oracle databases support granting privileges on schema privileges in addition to the existing object, system, and administrative privileges that is already coming from the earlier versions of the database. This feature improves security by simplifying authorization or database objects, especially for schemas that frequently add new objects instead of granting um, broad system level, that is star any, that selects grant any and all that privileges that apply to the entire database. Privileges can now be granted at the individual schema level. Now moving on to the developer role. A new rule allows administrators to quickly assign developers only the privileges that they need to design, build, and deploy application to the Oracle database. Um, the DB underscore developer underscore role provides an application developer with all the necessary privileges to design, implement, debug, and deploy applications in an Oracle database. By using this role, administrator no longer have to guess which privileges may be necessary for application development. So it's very simple. Like generally, a DBA creates a schema and assigns to it profile. The profile may have like grant any, select any, and all those things. So rather than this version has come up with its own rule, that is DB underscore developer rule, where it is giving the specific role which are predefined and that it can be assigned to the developer. So it is a less headache for a DBA, and it's more important for the developer. So coming on to the SQL Firewall. Included in Oracle database, SQL Firewall provides real-time protection against common database attacks by monitoring and blocking unauthorized SQL and SQL injection attacks, no matter the SQL execution path. So, SQL Firewall provides a real-time protection against common database attacks. Okay, by restricting database access to only authorized SQL statements or connection. It mitigates the risk from SQL injection attacks, anomalous access, and credential thefts or abuse. SQL Firewall uses session context data such as IP address, operating system username, and operating system program name to restrict how a database account can connect to the database. This helps mitigate the risk of stolen or misuse application service account credential. A typical use case for SQL Firewall is for application workloads. You can use SQL Firewall in both the root and a pluggable databases, PDB and CDB. CDB is the root one. So this is all about SQL Firewall. Now coming on to the last feature, that is Azure AD auth integration. New feature which is a new functionality that enables single sign-on to Oracle database service instances or on-premises Oracle database from Microsoft Azure Cloud, hoping that you have your AD not on-premise, but you are using Microsoft Azure Cloud, which the JDBC support for OAuth 2.0, including OCI, IAM, and Azure AD. The Oracle JDBC driver provides support for OAuth 2.0 authentication for Oracle Cloud Infrastructure, that is OCI, Identity and Access Management, that is IAM, Cloud Service, or Azure Active Directory. So the Active Directory which is set up in cloud, in Azure Cloud, that too, that is a Microsoft Azure. This feature simplifies Java application authentication to the Oracle Autonomous Database using OAuth 2.0 in multi-cloud environment, OCI Azure, in lieu of traditional credential mechanisms such as username slash password or strong authentication mechanisms such as Kerberos or Radius. So this is all about the features of Oracle 23C database, which is more developer centric. Thank you for watching this video. Please do comment and update me if you want to know about more videos or any new topic um, that you want to understand. I'll be more than helpful and bring you those videos to you. Thanks for watching Gadgets and Software. Like, share, and subscribe to my channel. Thank you.